In this video, we're going to learn how to sketch graphs using knowledge of proportionalities. So here we've got a question. They list Newton's law of universal gravitation. Even if you don't know this law, that's okay. They say to sketch a plot showing the variation of m1 with m2. Whenever they say how m1 varies, or the variation of m1, that means m1 is on the y-axis. And when they say with m2, m2 then is on the x-axis. That's how we decode this, this writing. Then you take this and you write down the proportionality, and in place of m1 you put y, because it's on the y-axis. In place of m2 you put x, because it's on the x-axis. And then everything else becomes a 1, just like we learned in our proportionalities. So I have 1 for fg is proportional to, this becomes a 1, times m1 becomes x, m1 becomes y, m2 becomes x, we have 1 squared in the bottom, the r becomes a 1. So now we simplify. The right side is 1 times yx over 1 squared, which is the same as just yx. Now we always isolate y. So to isolate y, I divide both sides by x, and I see I've got an inverse proportionality. So I draw the graph of an inverse proportionality, which is what I've shown right here. I've memorized this shape, and that's how I do it so quickly. Now number 4. Sketch a plot of the variation of elastic potential energy with compression distance. So because they say variation of PE, that means PE, elastic, is on the y-axis. And because they say with compression distance, that means compression distance x is on the x-axis. Okay, now I look at the equation and I write it again, but this time as a proportionality. PE changes into y, because it's on the y-axis. The 1/2 here, this is going to become a 1, that's going to become a 1, and x, my compression distance x, on the right side, my compression distance x remains an x, because it's on the x-axis. So then I just sketch the graph for a square proportionality, and I've memorized that shape. It's this. Let me try that again, a little smoother. Something like that. Okay, number 2. The equation for oscillatory period of a pendulum is t equals 2 pi radical L over g. Assuming g is fixed, sketch a plot showing the variation of t. Aha. Variation of t, that's the y-axis, with L, so L is the x-axis. So I take this equation and I rewrite it. And what do I have? I have t becomes y is proportional to, the 2 and the pi become a 1, so I'm not going to write them. And then I have radical L is x now, because L is on the x-axis, divided by 1, so I don't have to show that. And look at what I've got. Y is proportional to square root of x. So I draw the square root graph shape, which is this. And I've memorized that shape. Number 5. Intensity of a sound is given by the formula I equals P over 4 pi x squared. Sketch a plot showing the variation of intensity I with position x. Okay, so what do? I take this equation, and first I say, we've got variation of intensity. That means intensity is my y-axis. And they say with position, which means my position x is the x-axis. And then I take this equation and I write it again, but this time I do a proportionality. So I, intensity, is on the y-axis, so that becomes y. The equals goes to a proportional symbol. P is a constant, so it becomes 1. 4 and pi are all constants, so they become 1, so I'm not going to show them. And then I have compression distance x, and it's already an x, so I keep it an x, because it's on the x-axis. And what do I have? This is inverse square, so I draw the inverse square shape. Something like that, maybe. Okay, number 3, we're kind of jumping around. Sketch a plot showing the variation of net force That means F net is my y-axis, because it's variation of net force, with acceleration. So acceleration is my x-axis, assuming mass is fixed. Now, you've noticed this by now. They don't always say for you to assume that the other stuff is fixed, but that's what we do anyway. Regardless, we always assume the other things are fixed. Okay, so what's the equation with F net in A? Oh yeah, it's Newton's second law. F net equals ma. Now I would give the equation on a quiz or test, but here it's fun to try and remember. Okay, so F net, that's the y-axis, so I change that to y. I'm writing a proportionality now. Mass is fixed, so it becomes a 1, so I'm not going to show it. Acceleration is the x-axis, so I have a direct proportionality, this.